Question 25 says OA, BC, and OPQR are parallelograms. A is a point on OP and C is a point on OR. OA equals to A, OC equals to C, OA ratio OP is 1:4, and OC ratio CR is 2:3. Find OR in terms of C. CR is OR minus OC. So that means CR plus OC is going to equal to OR. CR is going to be OC is C. And for CR, what we'll do is OC over CR is 2/3. So that means it's going to be C over CR equals to 2/3. And CR is going to be 3C/2. So that's going to be 3C/2. So if we add them up, that's going to be 5C/2. That is OR. Then it says, find CQ as simply as possible in terms of A and C. We know that OR was 5/2C. So CR is going to be 5/2C minus C, which is going to be 3C/2. If this is OA and OP is given as 4, that means it's going to be 3A. And this total, since these are parallel, that's going to be 4A as well. And we're trying to find CQ. So CQ is going to be CR plus RQ, which is going to be 3C/2 plus 4A. Then find the ratio of area OABC to area OPQR. So in part C, what we'll do is that if you look at the shape, we already know that this distance, like this vector, is 2.5C or 5/2C. And we know that this entire vector is 4A. So if we divide the entire parallelogram into boxes, just to get a better idea of what the area is going to be, divide these into 4 columns, and we divide these into 2.5 rows. Okay. This is going to be first box, second box, third box, fourth, fifth, sixth, seventh, eighth. Now, since this is C and this is C, this is 0.5C, like half of C, which means these two boxes add up to one box, and these two boxes will add up to another box. So 2 boxes in total. So we count the total boxes, that's 10 boxes for the parallelogram OPQR. And for the parallelogram OABC, we have 1 box. So now if we write the ratio of the area of OABC to OPQR, that's going to be 1:10. That is your answer.